Well, hello there, Codemaker4 here. So, Advent of Code, day 2, it's going. Cube Conundrum. Of course, do the puzzle yourself first. I assume that you've already done it. But long story short, there's going to be these sets of games where an elf grabs cubes out of a bag. And we're going to see how many cubes they can grab out of the bag. And based on how many cubes we see at once, we need to determine whether or not that game is possible. Because there are only 12 red, 13 green, and 14 blue cubes. So for example, in game 4, the elf grabs 15 blue cubes out of the bag, but we know there's only 14 blue cubes. So we know that game 4 is impossible. Then what you have to do is find all of the games that are actually possible because they don't exceed these limits, add them together to a sum and give that back. Easy peasy. Or at least it's easier said than done because I'm a maniac and decided to program this in C. Luckily, I could still recycle the isDigit function from the previous challenge, but I have to create this read integer function. And oh boy, the pointer math, it's fun. As you can see, we have the double pointers. So basically what this does is it gets a pointer to a string. Wait, let me show this. So whenever you get confused about pointers, just draw it out. Yeah, that's a good example string. So I have this pointer, right? It's pointing to the first character of the string. So the pointer we call str points to the first character. So say we just execute this read integer function on this string over here. So 1, 2, 3, ASD. Pointer is first going to point to 1, and we're going to do read digit. So read digit is going to return 1. So this stuff doesn't happen. Instead, because num is still uninitialized, we're just going to set num to 1. So now num is equal to 1. And then we do pointer to string, which is a pointer. I should really rename the string pointer. So we're going to basically increment the pointer here. So that the pointer, what this means is that the pointer is now going to be here, pointing to the 2. And basically we do everything again, but now num is set to 1. We read the digit 2. We're taking this 1 that's already in there, multiply it by 10, and then add 2 to get 12. And then we increment the pointer again. So again, this gets incremented. Now we're pointing to 3. So we read the digit 3. Num from 12 goes to 120, then we add 3 to get 123. We increment the pointer again. So now we are reading A. A is not a digit, so this is -1. We did read some numbers, so num is not equal to -1, so we're just going to return the number. So read int returns the number, but of course read int is always executed in some sort of context where you're trying to process a string. So what happens is because you give it a pointer to the first character of a string, so kind of a pointer to a string, and we're actually kind of able to modify the start point of that string in the original context. So, and this is really useful because after we've read the number, we don't really need this previous part of the string anymore. So this point is going to be adjusted to the kind of new start of where we still need to process stuff. And this is a trick that I'm going to use like throughout. So here's the main function. We get our input, put like a little example line here. So this is what our input looks like. So first of all, I'm just doing a bit of a sanity check if there's actually game on that line, because we might have an empty line because it's the last line of the input, for example. So if it starts with a capital G, we know it's good. We are not going to do like full-on string comparisons here. That's just not necessary because this input is so well formatted and so like reliable that I can get away with just reading the first character of words. Let's just keep track of this pointer. So this pointer is being set to the start of the line +5. So if this pointer gets equal to the start line +5, so 1, 2, 3, 4, 5. And then it's set to the start of the number. So we go over here and read that integer. So this integer is being read, and depending on how long it is, the pointer is now going to be equal to after the semicolon. Because over here we're giving it a reference to that pointer. So readInt is actually able to modify where this pointer exactly points to. Then we're going to skip 2 more characters, which is because of the double dot and the space. And after we've skipped 2 more characters, we're going to be landing on this 3. And this is where we start the main loop. So we need to check if the game is invalid at some point. So we just have this game going variable. And once it's invalid, we just set this to 0. So we read that integer and we skip the space after the number. So we read and skip the space after. That is going to be set to the first letter of a color. Because each of these colors start with a different character, you can just check the first character in this switch case. And if the number we read is more than the red max, so you just set game going to 0. Pointer plus equals 3, because the color red has 3 letters in it. So we then skip to the kind of character after that color. Let's do an example. So in our example, the character over here is B. So this case over here is going to happen. The number we read is 3, so there's 3 blue cubes, which is less than the blue max, so this is not going to happen, but we're still going to increment the pointer by 4. So 1, 2, 3, 4, get to the comma. So after the switch statement, we just check if it's a comma or a semicolon. In both cases, we increment the pointer by 2 to skip that character and go to the next number, to also kind of skip the space after it. And if there is no character, then it's probably like a new line or a null, because we've reached the end of the string, in which case we just stop the loop because we're done. So this loop executes a few times until we reach the end. So either this break or game going is set to 0. And if so, whether based on if the game is still going after the loop has finished, then it means that we've reached the end of the game string without finding any sort of invalid stuff. So we know that this game is good and we're going to add it to the sum. If game going is 0, then we know it stopped in one of these cases. So we don't want to do that. And we increment the game ID. It's like the alternative is that I actually like read the game ID and save it here. Both are fine. Perhaps it's actually better to just read it in case the game IDs are not actually in order. Again, I'm making a lot of assumptions about the input here, but they give a pretty... These assumptions are valid for the input they gave me, so this works. And we just print the sum. That's it for challenge A. And in this case, challenge B wasn't that much harder. So for the challenge 2, basically the only thing that changed is that we now need to calculate what the minimum number of required cubes is. So there's no longer, the elf no longer says to us that there's only so many cubes in the bag, which of these games are invalid. Instead, it's just asking us how many cubes do there need to be at least for that game to be valid, which is really just asking us what's the highest number of cubes for each color in each game. Then what you have to do is you have to multiply all those numbers together for each game to get a sum of that game, and then add the sums of all games together. And this didn't require a lot of modification to the code. Digit and read, int, all of those are still the same. The main thing I changed is that these red max, green max, blue max are now minimums, and they're now defined inside the loop of each game. So at the start of each game, they're going to be set to 0. And then instead of, if they're larger than the minimum, we're just going to stop because the game is invalid. Instead, we're just going to set the new minimum that we found. It's actually a maximum. Yeah, this is a bad name. So we're just going to keep track of the highest number of cubes we've ever seen. And most of this algorithm stays the same, except that at the end the sum is going to be incremented by red times green times blue. I am going to change these variable names back to max on the GitHub. Anyways, that's it, kind of. What's the complexity of these? Both of these are O of n. Perhaps even slightly less because we skip a few characters, but O of n. Anyways, I'm CodeMaker4. I'm live tonight on Twitch. Subscribe for the video of tomorrow. I still don't have an outro. I should make one at some point. Anyways, bye.